This meeting is being recorded.
Assalamu alaikum and hello. This is Ahmed Zaki and I'm here with my groupmate, Fathan. And we are group 13 from section 2 of computer organization and architecture. This video is intended to showcase our Lab 1 solution. And we're going to start with the Lab 1 part A. So part A is about doing arithmetic operations, mainly subtracting and addition for integer values. So we can start by looking into the source code. You can see that we have like the total variable. So this variable is the variable where we're going to store our final result. So let's start with by loading our first integer value, that is 1, 2, 3, 400 into our EX. Then we are going to add 5, 6, 7, 800. Now after we have done with the addition, we are going to subtract 700. With this, we have done the arithmetic operations we are aiming to do. Next, we are going to store the result on the total variable, and we are going to call dump breaks to actually see what's happening on the register. So as you can see in the right side, we have the registers. You can see all the changes happening. And then if you look into the watch to further understand our variables, you can see that the total have been edited, so it have changed. And yes, I think this marks down like everything related to our lab one, part A. I think now we can move on to lab one, part B. So for the variables here, we are going to have three variables, and the fourth variable is gonna be like the variable where we're going to store the final value. Soon you will be able to see this in the source code. This is the source file, as you can see. So as you can see, we have from line 8 to line 10, we have our values or our variables. Uh, each one of them have like its own value. And in line 11, we have the final value. It currently doesn't have a value. And we are going to store our final value inside this variable. So first of all, we are going to load value 1. Okay, 1 minute. Okay, we are going to store value 1. And then we are going to add value 2, followed up by subtracting value 3. We have done our arithmetic operations, and we're going to store in line 17. As you can see, we have stored our value in the final variable. Currently it holds the final value, and if we go to the watch, we have the final value here have been edited, and this is the final value. And as you can see in the right side, you can see like what our registers. And with this, I believe this marks like the end of our lab one, lab one part B. So just to recap what we have done. So in lab one part A, we have uh, we have tried doing the arithmetic operations on the integer values, and then we call dump breaks to showcase our registers. And in lab 1 part B, we have done the same but using variables instead of integer values. And again, we have stored our final result in the variable, the final value variable. And afterwards, we have called dump breaks to check our registers. And this marks like the end of both part A and part B, and we will be moving into part C next.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fathan Rasi Mohammed. My matrix number at1EC4045. Today I want to present the debugging process of the part C. So as you can see in here, I set the breakpoints in every main process in the program of this assembly. So we run. So in here there is a memory and also registers and watch. So we can see one by one the process of each line of code. In here we want to check every address of the variables. File1, you can see in here this is the address, and then this is the little endian, and then because the AX is still not yet executed, so it's still at arbitrary number in here in watch AX. This is not the real number, so we can test the file v2. Okay, this is the address, and then this is the little endian, and then we can check the file v3. So this is the address and little endian, and then we can see the final file way. Okay, so because the final file way is still not assigned, so this is still 0. So this is, as you can see, the little endian is a lot of 0 in here. And then we can check the file file b1. So this is the address, and then file b2. So this is the address, and then file b3. So this is the address and little endian. Okay, now we jump into the process in here. So we can see in the watch, and then as you can see, this is the real value of the each of variables from the file 1 until file b3. You can see in here, and then we focus on the value of AX, AH, final file Y, and then final file B. Okay, let's start. So first is in the breakpoints, as you can see, we move from this line 20, and then we can continue. And then you can see in here, the AX is move file W1 into the register AX. So this value is assigned to here, to the register AX. And then also there's some changes in here. AX is now updated, and also AIP is the register. And then in the disassembly, we can see in here per line of code, this is the address, and then we can track down the every process in here on every line. And then we continue. Now we add the file w2 to the AX. So we continue, and then we can see the change in here. F5000, previously I think this is not same figures, and then as you can see in here, AX is changed. So for 4000 add by 6000 something, so we can see the new value is 20,000. So the value of AX is updated in here, and then we continue again to the subtract in here with the file w3. So we can see in the watch, and then also this is change, right, from the 5000 as far as I remember to 3000 in AX. And then in here the AX is 12,000. So from the 20,000 to 12,000. So this proof of this program change the value inside the register. And then finally we move the register AX to the variable final file W. So in here still 0, right? If we continue, we can see the final file W is 12,000. So this is the final value is updated. Now we move to the AH register. So initially the AH so must be file B1, right? But this is still not yet executed. So we move again. So this is the okay. So this is the AAX and AIP is changed again. So in here we can see the value file B1 is assigned move into the register AH, and then we can add in here in the next line. So file B1 add by file B2. So ATP, and then we continue again, and then lastly the file B3, the value in AH is subtracted by file B3. So this is 480, and the last because this is still 0 and the last, so the final file B is executed and then it is moved into the final file B. So the from AH to the final file B, as you can see. Okay, so this is the last line of code we have executed. So we can see the change in here in EIP and EAX, and then we can see the address and then little endian, and also we can watch every step process and then the value updated inside the watch. Okay, that's all from me. Thank you for the debugging.